All right, practice E, we're going to look at number 3. It says a projectile is fired at an angle of 53 degrees with the horizontal. The speed of the projectile is 2 times 10 to the 2 meters per second. So calculate the time it remains. So first of all, I'm going to draw a picture. That's always step number 1. So I know what type of problem it is. Now this one's going to look like this. This is my initial velocity. Why am I going to bother drawing this for everyone? Because when we have our test and we have one FRQ that's horizontal and one that's an angle, I should have my picture so I make sure I'm working the right type. So you want to draw your picture. So this is VI. I know VI is 2 times 10 to the 2 meters per second. They told me this angle here is 53 degrees. And I know with a problem like this horizontal displacement x is called the range. So what do we want to find in this problem? We want to find A, the time it's in the air, so that's the total time t. I want to find B, the horizontal displacement, which is x. And that's it. Oh, this one's easy. So I'm going to first write my given, and I'm going to do my given. I'm always going to do x and y given. So the first thing I'm going to do on every projectile motion problem is I'm going to write ax is 0 and g is equal to negative 9.8 meters per second squared. Always, always, always. The next step is I'm going to take my initial velocity and I'm going to break it up into its horizontal and vertical components if it's not given. So VIX and VIY. So now I have to find that. So just to the side, remember this is the path, but to the side, that initial velocity, I'm going to write VI is equal to 2 times 10 to the 2 meters per second. And now, from where I start, this is going to be VIX. From the head of this vector, I'm going to do the tail of the other, and this is going to be VIY, and this angle here is theta. Now, let's say you're not sure. Do I use sine, or I use cosine, or I don't know? Well, let's just start with the first one. I know sine of theta is equal to opposite over hypotenuse. So now I'm going to look at my little triangle and say sine of 53 degrees, because this is 53, is equal to opposite. What's opposite? VIY. Over the hypotenuse, which is 2 times 10 to the 2. Now, after this point, this is algebra. When you multiply this, this goes in the front, not after. So I'm going to have VIY is equal to 2 times 10 to the 2 meters per second times the sine of 53 degrees. Now, the correct way to put this in my calculator is, what I do first is, I'm going to do this. So I'm not going to multiply this times 53. I'm going to say 53 sine times 2EE2 equals, and I'm going to see that VIY is 159.7, so I'm going to say VIY is equal to 160. Now VIX is going to be equal to VIX is going to be 2 times 10 to the 2 cosine of 53. How do I know it's cosine? It's adjacent to the given angle because cosine is adjacent. So if this step is too much for you, write cosine of theta is adjacent over hypotenuse, substitute in your values, and then multiply through. So when I do that on my calculator, Well, actually, I'll do it so you can watch. So 53 cosine times 2EE2 equals, so it's about 120. So now VIX is 120 and VIY is 160. But remember, whenever I do problems, I have to have 3 things. So I need something else. They don't tell me anything else. But I'm going to say, from where I start to where I end up, my vertical displacement is 0. So now I know that y is equal to 0, and I have 3 things. Now, like we saw a minute ago, I could use the equation y is equal to VIT plus 1/2 GT squared, but what happens when I do that? Quadratic. So I can use the other equation. So either way you do it, you're going to solve for the time. So we could use the equation VFY is equal to VIY plus GT. So VFY minus VIY over G is equal to T. So I didn't write VFY in my given, but I can write that VFY is equal to negative 160. Remember, it's equal in magnitude because VF is here, but VFY is going to point down. So it's equal in magnitude but opposite direction. So that's going to be, VFY is going to be negative 160 minus 160 divided by negative 9.8. So when I do that, 160 divided by 9.8, the negative in the numerator cancels with the negative in the denominator, and I get the time is equal to 33 seconds. It comes out to be 32.6, so we'll just say 33 seconds. Okay, now we're going to do part B. So part B says how far does it go? So we want to find x. So now we're going to have to apply our equations horizontally. We want to find x. We have VIX. And we also have t, because remember, t is the same. So if t here is 33 seconds, it's going to be 33 seconds here. So I also know t. So the original equation is x is equal to VIXT plus 1/2 AXT squared, but AX is 0. So if you know, when I'm doing projectiles, I don't want to write down the whole equation because I know AX is 0. This is my equation. I just don't think it's correct because people get confused to memorize like, oh, here's a brand new equation to find the horizontal displacement for projectile motion, because it's the same as the equations we did before. It's just that there's no horizontal acceleration, so that whole term drops off. So x is equal to VIX, 120 meters per second, times the time, which is 33 seconds. So my seconds cancel, so I end up with meters, which is the correct unit. And then 120 times 33 is equal to 3960. So x is equal to 3960 meters. And that's it. So even though they didn't give me the initial and the horizontal and vertical components of the initial velocity, wasn't it really easy just to find them myself? To find VIX and VIY? Whoops.